Well, how do we solve this limit? It may look pretty difficult, but it's actually pretty simple. So this is a triple variable limit where we have variables x, y, and z, and they all approach the origin. So what we have to do is we have to first recognize that x squared plus y squared plus z squared equals rod squared. This is the standard equation of a sphere. Similar to a radius where x squared, like a circle where x squared plus y squared equals r squared, this rod squared basically is really similar to the radius. Very similar. It's basically the radius of a sphere. So rod is the radius. So a little introduction to spherical coordinates before we go further. I'm going to draw a 3D graph. So we'll have three components to this spherical coordinates. First, we will have phi, which is right here, which is basically the angle from the z-axis. I'll label them. Then we have rod, which is the radius itself. And we have theta, the one that we should all be familiar about. It's the one that goes from 0 to 2 pi, and it goes around the x-axis. So you should know that. So in a sphere, these three sets can be used to describe any point within the sphere, like a full sphere. It can be described within any point. All right. So from this, we can deduce that x equals rod sine phi cosine theta, because this is a bad illustration, but cosine theta is basically just the adjacent side, which corresponds to a spot on the x-axis. Y equals rod sine phi sine theta, because in theta, the sine corresponds to a y increase, which is right here. This corresponds to that. And z is rod cosine of phi. So phi, the cosine of this angle, would just be the adjacent side, which is like right here. So, and then this rod is just a multiplier depending to scale. So this corresponds to a z position. So now, before we substitute all these values, we have to change this limit itself. How will we do that? Well, the reason we actually put in spherical coordinates in the first place is the fact that when we have the rod itself, if rod is approaching 0, this means we straight up approach the origin. Yes? So if we just say that the limit of rod, I'm fixing this. If we say rod as it approaching 0, we get the limit as before. So now we can get the substitution. So x is rod sine phi cosine theta. Y is rod sine phi sine theta. And z is rod cosine phi. Over, we know that this is p squared from the equation of a sphere. There we go. So now we have this limit. So we will simply evaluate it. So we have limit of rod as it approaches 0. Rod cubed if we multiply these all together. And then we get the rest of this junk basically, which I'm going to symbolize with the letter K. It's just symbolizing junk. So rod cubed times K, which is all the trigonometry, over p squared. Now p cubed over p squared just equals p, right? So we can say that the limit of p as it is approaching 0, we have p times k. Well, k still is the trigonometry. Now, since we have this, we can just do a direct substitution. Say that p is 0. So this thing goes to 0. Therefore, we have 0 times k. That's the answer, 0. That means the limit of all these variables as they approach 0 just equals 0. How nice.